Welcome back to the Deep Dive. Today we're plunging headfirst into a topic that, well, it really touches everyone, yet often feels like a bit of a hidden mystery. Understanding and maybe even restoring a dysregulated nervous system.
It's so foundational, isn't it? I mean, how we feel, how we function day to day. Our source material for this deep dive is this really comprehensive report on supporting the dysregulated nervous system.
Yeah, it looks pretty thorough.
It really is. It gives us a kind of roadmap through this complex inner landscape we all have.
Absolutely. And our mission today really is to take that roadmap and, extract the most important insights for you. We want to unpack how your nervous system can get thrown off balance by, well, all sorts of things: stress, diet, even exercise sometimes.
And then explore the evidence-based ways the report details for bringing it back into alignment. How to find that balance again.
Ready to navigate the complexities.
Let's dive in.
Okay, so to understand dysregulation, I guess we first need to grasp how the system is supposed to work, the baseline, right? Let's start with its fundamental job, keeping your body's internal environment stable.
Right, maintaining homeostasis. Think of your nervous system as the ultimate command center. It's constantly monitoring and adjusting everything, keeping things running smoothly. And a huge player in that is the autonomic nervous system, the ANS.
The automatic pilot.
Exactly. It handles heart rate, breathing, digestion, all the stuff you don't consciously control, the background operations.
Right, you're not sitting there thinking, okay, heartbeat now, digest that food.
Precisely. And the ANS has its famous subdivisions. First up, the sympathetic nervous system, the SNS.
Ah, the classic fight or flight. Everyone's heard of that one.
That's the one. When your brain perceives a threat, and it could be an actual physical danger or, just intimidating email, the SNS slams the accelerator.
Everything ramps up.
Yeah. Heart pounds, blood pressure spikes, breath quickens, muscles tense up, senses sharpen. It's frankly brilliant for getting you out of immediate physical danger, like evolutionary gold.
Which brings us to a core insight from the report, doesn't it? This evolutionary mismatch.
Exactly. This system is designed for intense, short bursts. Escape the lion, fight the attacker. But our modern world, it throws constant chronic stressors at us.
Traffic jams, work deadlines, social media pressure.
Right. And the SNS just stays engaged. It gets stuck in this high alert state that it really wasn't built for long term.
And that takes a toll.
A big one. The report calls the cumulative toll of that chronic activation allostatic load. It's essentially the wear and tear on your body from trying to constantly adapt to those stressors.
That makes so much sense. It's not just feeling stressed, it's an actual physiological cost accumulating over time.
Absolutely. Now, the counterbalance to the SNS is the parasympathetic nervous system.
A PNS.
The rest and digest system. This is where things are meant to calm down. Precisely. Heart rate slows. Digestion gets priority. Energy is conserved. It's crucial for, long-term health, repair, recovery, all the rebuilding stuff.
And the report mentioned something surprising about the PNS, didn't it? Beyond just calming down.
It did, and this is fascinating. The PNS isn't just about relaxation. It has a significant direct influence on your immune system. Specifically via the vagus nerve, it helps mediate an anti-inflammatory reflex.
Wait, hang on. So your rest and digest system is actively helping to dial down inflammation in your body.
That's what the evidence suggests. It's actively working against inflammation.
That's powerful. So if your PNS is suppressed because you're chronically stressed out, you're actually losing an active anti-inflammatory mechanism.
Exactly. It connects chronic stress directly to inflammation on a really fundamental physiological level. It's not just a psychological link.
Okay, wow. And there's another part of the ANS too, right? The second brain.
Ah, yes. The gut. The enteric nervous system, or ENS. It's this incredibly complex network embedded in the walls of your gastrointestinal tract. It has as many neurons as your spinal cord.
That's amazing. As many as the spinal cord.
It's wild. And it manages digestion with a surprising amount of autonomy.
Like a regional manager handling local operations without constantly checking with HQ.
That's a great analogy. But, and this is key, it's in constant communication with the brain, mainly through that vagus nerve we mentioned. It's a two-way street, a bidirectional highway.
So what happens in the gut doesn't stay in the gut.
Absolutely not. It profoundly influences the brain, and vice versa. If your ENS gets dysregulated, it can definitely throw off your overall nervous system balance. The gut is way more than just a digestive tube. It's a major sensory organ constantly reporting back to the brain.
Okay, so that's the ANS, the rapid response, and the recovery systems, plus the gut's own brain. But stress also involves hormones, doesn't it? The longer-term response.
It certainly does. That brings us to the hypothalamic pituitary adrenal, or HPA, axis. This is the body's central stress regulator, a kind of neuroendocrine loop.
Okay, walk us through that loop. What happens when stress hits this system?
Sure. So, stress triggers the hypothalamus in your brain to release CRH. This signals the pituitary gland, also in the brain, to release ACTH. ACTH then travels through the bloodstream to the adrenal glands sitting on top of your kidneys.
And the adrenals release.
Cortisol, the main stress hormone. Adrenaline gets released too, more immediately, but cortisol is the key player in this HPA axis loop. It mobilizes energy, suppresses non-essential functions like digestion or immunity temporarily.
And in a healthy, balanced system,
Yeah.
there's an off switch, right? It doesn't just keep pumping out cortisol.
Exactly. There's a negative feedback loop. As cortisol levels rise, they signal back to the hypothalamus and pituitary to stop releasing CRH and ACTH. Things return to baseline, equilibrium restored.
But the report emphasized how chronic stress messes this up.
It really hammers this point home. Chronic stress basically breaks that feedback loop. The system becomes less sensitive to cortisol's stop signal. So you end up with persistently high cortisol levels, and the HPA axis itself becomes dysfunctional.
Which sounds like the definition of being stuck on.
It really is. And this persistent high cortisol, this HPA dysfunction, that's the core mechanism behind that allostatic load we talked about. Eventually it becomes allostatic overload, where you tip into chronic dysfunction.
So that continuous pressure on the system, whether it's from, physical stressors, emotional stuff, environmental toxins, it all adds up.
It accumulates, and the report is clear this isn't just some abstract concept. This cumulative cost significantly increases your risk for a whole host of problems. Immune issues like autoimmune conditions, chronic inflammation, certainly mental health challenges, mood disorders, anxiety, PTSD, and even metabolic diseases like type 2 diabetes or cardiovascular issues.
And lifestyle factors pile on too.
Absolutely. Things like smoking, a poor diet, lack of quality sleep, they all add to the allostatic load. It's a unifying idea that helps explain how so many different kinds of challenges can all lead to measurable physiological dysregulation across the body.
It's a tangible burden, a weight on the system. And the brain itself isn't spared, is it? It feels this pressure too.
Far from it. Chronic stress profoundly impacts the brain's chemistry, its neurotransmitters, and quite remarkably, even its physical structure.
Neurotransmitters.
Yeah.
Those are the brain's chemical messengers, right?
Exactly. They're running the show up there. You've got serotonin, involved in mood, sleep, appetite, anxiety regulation. Dopamine, crucial for reward, motivation, pleasure. Norepinephrine, part of that fight or flight system, alertness. GABA, the main inhibitory one, promoting calm, reducing anxiety. And oxytocin, often called the bonding hormone, also important for stress reduction.
And when these guys are out of balance?
Well, that directly contributes to conditions like depression, anxiety disorders, focus issues, you name it. Too high, too low, it throws things off.
And stress is a major disruptor here.
Definitely. Both those sudden, acute jolts of stress and that chronic, grinding kind can dysregulate key players like serotonin, dopamine, and norepinephrine. But remember the gut connection.
Ah, yes, the ENS and the microbiome.
The report really reinforces this. The gut microbiome doesn't just talk to the brain. It actively synthesizes neurotransmitters or their essential precursors. It's a massive influencer of your brain chemistry.
So supporting your gut health can actually directly impact your mood and how you handle stress.
That's a key takeaway. Gut health isn't just about digestion. It's intrinsically linked to brain chemistry and resilience.
Mind-blowing. Okay, what about the structural changes in the brain you mentioned? Stress actually changes the physical brain.
It does. It causes actual structural remodeling, as the report calls it, in key brain areas that are heavily involved in processing stress and emotion.
Which areas are we talking about?
Primarily the hippocampus, which is vital for memory formation and putting experiences into context. The amygdala, which is like our emotional alarm system, especially for fear. And the prefrontal cortex, the PFC, that's the executive control center, handling decision-making, planning, and importantly, emotional regulation.
And chronic stress damages these areas.
It can. The report details how chronic stress can make the brain's resident immune cells, called microglia, become dysfunctional. Normally, they're helpful housekeepers, cleaning up debris. But under chronic stress, they can go rogue.
Rogue how?
They start excessively pruning synapses, those crucial connections between neurons. They can even directly damage neurons in these key regions.
Excessive pruning sounds like losing important pathways or connections.
That's exactly what it is. In the hippocampus, studies show stress can lead to shrinkage and impaired memory function. Reduced hippocampal volume is actually a known feature in PTSD, linked to intrusive memories and difficulty distinguishing past trauma from present safety.
And the amygdala.
It tends to become hyperactive, hypersensitive, especially in conditions like PTSD. This contributes to intense fear responses, hypervigilance constantly scanning for threats.
And the PFC, the control center.
Chronic stress can cause dendrite shrinkage. The branches of neurons retract. The report links this to cognitive rigidity, that feeling of being mentally stuck or inflexible. And decreased activity in the PFC, particularly seen in PTSD, means it's less able to put the brakes on that overactive amygdala. This worsens emotional dysregulation. You lose that top-down control.
So stress doesn't just make you feel bad. It's literally changing the physical wiring of your brain over time.
Yes. The brain's amazing ability to change, its plasticity, is normally adaptive. It helps us learn and cope. But under chronic stress, this plasticity becomes, as the report puts it, a double-edged sword. It leads to maladaptive changes.
Meaning the brain rewires itself in a way that actually reinforces the stress response.
Precisely. It can cause a loss of resilience. So interventions need to go beyond just managing symptoms. They need to actively target reversing these specific brain changes, promoting positive adaptive plasticity.
And a major driver of this brain damage, the report highlights, is inflammation within the brain itself, neuroinflammation.
Yes. Chronic inflammation in the body often goes hand in hand with inflammation in the brain and spinal cord. It contributes to nerve damage, neuropathy, that dysfunctional microglial activity we just talked about, the excessive pruning, the neuronal damage in the PFC, hippocampus, amygdala that's largely driven by neuroinflammation. It impairs memory, cognition, emotional regulation.
And it can be triggered by lifestyle factors, too.
Definitely. The report even cites research showing that something like a high-fat diet can trigger an early inflammatory response in the brains of mice, activating those microglia and potentially setting the stage for neurodegeneration later on.
So tackling neuroinflammation isn't just about reducing symptoms. It's about protecting the physical integrity and function of your brain.
Absolutely. It's a core piece of the restoration puzzle. Now, let's maybe zoom out just a bit. It's crucial to understand the nervous system isn't operating in isolation. It's deeply interwoven with other major systems in your body.
Like the immune system, which we've touched on a few times.
Exactly. The neuroimmune axis. These two systems are in constant bidirectional communication. It happens hormonally, like via the HPA axis. Cortisol directly affects immune cells. And it happens neuronally. Nerves directly connect to immune organs, and immune cells actually have receptors for neurotransmitters. They're listening to each other.
And when this communication system gets dysregulated,
Problems arise. You might see the immune system go into overdrive, leading to chronic inflammation or autoimmune conditions. Or, conversely, it could become suppressed, increasing your risk of infections. But critically, the immune system also signals back to the brain.
how does it do that?
Primarily using chemical messengers called cytokines. These inflammatory molecules can cross the blood-brain barrier, or they can signal the brain indirectly via nerves like the vagus nerve. And this is fascinating. These cytokines can actually induce what are called sickness-related behaviors.
Sickness behaviors.
Yeah.
Like when you have the flu.
Exactly. That feeling of fatigue, low mood, wanting to withdraw, loss of appetite, sleep changes. Inflammatory cytokines circulating in your body can cause those feelings and behaviors even if you don't have an active infection, just from chronic inflammation itself.
So chronic inflammation, maybe from gut issues or an autoimmune condition or even just lifestyle, can directly make you feel depressed or fatigued by signaling the brain.
That's the connection the report makes very strongly. Inflammation is presented as a central driver of nervous system dysregulation. It alters neurotransmitters, impacts mood and cognition centers in the brain, and drives those sickness symptoms. Any effective strategy for nervous system restoration has to address and reduce systemic inflammation.
Which brings us back to that critical gut-brain axis again.
This is probably one of the hottest areas of research right now, and the report explains why it's so vital. We've got the ENS, the second brain in the gut, and the main communication highway between the gut and the brain. It's that versatile vagus nerve.
The information superhighway or maybe the switchboard.
Yeah, connecting the brainstem directly to the gut and other organs. What's really key, and often underappreciated, is that most of the vagus nerve's sensory endings are in the gut. It's constantly sending signals up to the brain.
Reporting back from the front line.
Exactly. It's giving the brain a continuous status update on everything happening down there: nutrient levels, enzyme activity, immune responses, and crucially, the level of inflammation, also metabolism, gut motility, hormone signals.
It's a huge sensory input to the brain.
Massive. And the gut microbiome, those trillions of bacteria, fungi, viruses living in your gut, they are active participants in this conversation. They produce all sorts of chemical messengers like short-chain fatty acids or SCFAs. These travel through the bloodstream to the brain and influence mood, appetite, inflammation control.
And they can talk directly to the vagus nerve, too.
They can bind to receptors on those vagus nerve endings, sending signals directly up. And remember the neurotransmitters.
Yeah, the gut making serotonin.
The report confirms this is a major factor. Estimates are that up to 95% of your body's serotonin is produced in the gut by specialized cells influenced by the microbiome. Also, other key ones like glutamate. This direct influence on brain chemistry is profound.
So an unhealthy gut microbiome, maybe dysbiosis, means less production of good stuff, more inflammatory signals, and messed up neurotransmitter balance.
That's the picture. It disrupts the whole axis. Inflammation in the gut sends distress signals up the vagus nerve, contributing to anxiety, depression, brain fog. Vagus nerve malfunction itself is often seen in gut disorders, impairing communication and leading to motility problems or that LES relaxation involved in reflux.
So the report really positions gut health as a central regulator.
It argues that gut health is fundamental. Because the microbiome plays such a huge role in neurotransmitters and inflammation, gut dysbiosis is a major contributor to nervous system and mental health issues. Gut-targeted interventions are therefore presented as foundational for calming the entire nervous system.
Okay, we've built a really detailed picture of the foundations, the interconnectedness, and how things can go wrong, the mechanisms of dysregulation. How does this actually look? How does it manifest in real-world conditions?
The report uses several really good examples to illustrate these principles in action. One is overtraining syndrome, or OTS, in athletes.
Right, where exercise, which is usually beneficial, actually becomes the stressor that pushes the system over the edge.
Exactly. It highlights that anything, even something inherently healthy like exercise, can become a maladaptive stressor if the dose is too high and the recovery is insufficient. OTS is essentially the body's inability to restore homeostasis after excessive training load.
So the autonomic nervous system gets completely overwhelmed.
Yes, the balance is lost. Interestingly, the report notes different patterns. In the early stages, you often see sympathetic overactivation. The body is trying hard to cope. Think high resting heart rate, reduced heart rate variability, HRV, high cortisol. But if the stress continues,
It changes.
paradoxically, you can sometimes see a shift towards a kind of impaired parasympathetic state. Resting heart rate might actually become quite low, but the athlete feels persistent fatigue, maybe as fainting spells, poor performance. That low heart rate, which normally signals fitness in the context of OTS, can actually mean the system is dysregulated and recovery is severely impaired.
That's definitely counterintuitive. A low heart rate, but you feel awful and stuck.
Right. Understanding that nuance is key. And the HPA axis is central here too. The initial high cortisol response eventually gets overwhelmed and dysregulated. This can lead to symptoms often lumped under adrenal fatigue, though that term is debated, but basically severe fatigue, body aches, sleep disturbances, digestive issues. Overtraining can also mess with thyroid function and sex hormones.
So recovery protocols really need to support the HPA axis too.
Absolutely. And neurotransmitters and inflammation are deeply involved in OTS as well. Shifts in brain chemicals like serotonin, which tends to increase during prolonged exercise, and contributes to feelings of lethargy and dopamine, which is crucial for drive and motivation, contribute to what's called central nervous system fatigue.
And the inflammation.
Intense training causes microscopic muscle damage, which triggers a local inflammatory response. That's normal. But without enough rest, this becomes chronic and systemic. Pro-inflammatory cytokines like IL-6 and TNF-alpha circulate throughout the body.
And those cytokines signal the brain, causing those sickness behaviors we talked about.
Exactly. They impact centers in the hypothalamus, leading to loss of appetite, sleep disturbances, even depressive symptoms, alongside the muscle fatigue. So effective recovery from OTS has to tackle reducing that inflammation and helping rebalance those neurotransmitters.
Okay, another condition the report connects strongly to nervous system dysregulation is reflux, things like LPR and GERD.
Yes, laryngopharyngeal reflux and gastroesophageal reflux disease. While we usually think of them as just acid problems, the report makes a compelling case that they're often deeply rooted in gut-brain stress dysfunction.
How does stress specifically trigger reflux symptoms?
Several ways. Stress fires up the sympathetic nervous system. Those stress hormones, particularly cortisol, can actually relax the lower esophageal sphincter, that crucial muscle gate between the esophagus and stomach that's supposed to stay tightly closed most of the time.
So stress literally opens the gate for acid to come up.
It can contribute significantly. Stress also messes with the complex nerve signaling that controls the LES's coordination. Plus, it can delay gastric emptying, meaning food sits in the stomach longer, increasing pressure on that sphincter. And believe it or not, stress can stimulate acid production too, partly via the vagus nerve and hormones like gastrin. Chronic stress creates a perfect physiological storm for reflux.
So maybe managing stress and regulating the nervous system is more fundamental for some people than just taking acid blockers.
That's certainly the implication in the report. It also points to vagal nerve dysfunction being frequently observed in people with GRD. Impaired parasympathetic function, low vagal tone, seems to contribute to those problematic transient LES relaxations that allow reflux to happen. It can also impair esophageal motility and slow stomach emptying, making things worse.
And what about LPR, the silent reflux with throat symptoms?
For LPR, symptoms like chronic cough, throat clearing, sensation of a lump, globus, voice changes, the report suggests these might be linked specifically to chronic vagal nerve dysfunction and a resulting hypersensitivity in the nerves of the throat and airway, triggered by the initial reflex damage perhaps, but perpetuated by the nervous system dysregulation.
And the psychological piece is big here too.
Huge. Anxiety and depression are very strongly associated with GRD, often creating a vicious cycle. Stress and anxiety dysregulate the ANS, which can overstimulate the ENS in the gut, leading to improper LES function and reflux. The reflux symptoms then cause more anxiety. Managing the psychological aspects is presented as absolutely critical, not just an add-on.
Let's move to trauma and PTSD. The report uses a really powerful phrase to describe it: a reconditioned nervous system.
It's a profound way to put it. Trauma doesn't just leave psychological scars. It fundamentally, pathologically resets your nervous system. It reconditions it to prioritize defense above all else. You get stuck oscillating between states of high alert, fight or flight, or shutdown withdrawal, immobilization, dissociation, without being able to easily access a state of calm safety. The entire system is rewired for survival, even when the threat is long gone.
And we touched on the brain changes earlier: the overactive amygdala, the underactive PFC, the shrinking hippocampus.
Yes. The report really emphasizes that trauma literally remodels the physical structure and functional connections of the brain's fear circuitry. PTSD isn't just in your head, it's a tangible neurobiological state. Your amygdala is constantly screaming danger, your PFC isn't effectively regulating it, and your hippocampus struggles to put traumatic memories into their proper past context, leading to flashbacks and intrusive thoughts.
And the autonomic nervous system is right at the heart of this pathological reset.
Absolutely fundamental. The ANS loses its flexibility, its ability to smoothly shift between states appropriate to the actual environment. The report notes common findings like decreased high-frequency heart rate variability, HRV, and low vagal tone to the heart, which indicate a system biased towards sympathetic activation, ready for fight or flight even at rest.
This is where Stephen Porges's polyvagal theory comes in, offering a framework.
It provides a really helpful lens for understanding these states. Porges describes a hierarchy of ANS subsystems that evolved to keep us safe. The newest system, mediated by the myelinated vagus nerve, the ventral vagal pathway, is associated with feeling safe, calm, socially connected, and engaged. Below that in the hierarchy is the sympathetic nervous system, for mobilization, fight, or flight when we perceive danger. And the oldest system, involving the unmyelinated vagus, the dorsal vagal pathway, kicks in under perceived life threat, leading to immobilization, freezing, shutdown, or dissociation.
And the concept of neuroception.
Neuroception is Porges's term for the nervous system's unconscious process of scanning the environment and our internal state for cues of safety, danger, or life threat. It happens automatically beneath conscious awareness, and it reflexively shifts our ANS state accordingly. Safe cues. We shift towards the calm ventral vagal state. Danger cues. We mobilize via the sympathetic system. Life threat cues. we might shut down via the dorsal vagal system.
And in PTSD, this neuroception process is dysregulated.
Exactly. The system constantly mistakenly perceives threat even in safe situations, keeping the person stuck in those defensive, sympathetic, or dorsal vagal states, hyperarousal, or dissociation.
So from a polyvagal perspective, PTSD symptoms are essentially these adaptive defensive responses that have become stuck, maladaptive because the neuroception of safety is impaired.
That's the core idea. The low vagal tone, the persistent defensive states, they're seen as consequences of this dysregulated neuroception. Healing, therefore, involves helping the nervous system relearn how to accurately detect safety and regain access to that calming, connecting, safe, and social ventral vagal state.
And the HPA axis, the stress hormone system, is also deeply affected by trauma.
Profoundly. Chronic trauma often leads to significant HPA axis dysfunction. While patterns can vary, it often results in disruptions that increase long-term risk for immune problems, mental health issues, and metabolic disease. The report even notes research suggesting that early childhood trauma can lead to lasting alterations in HPA axis development and responsiveness, sometimes resulting in a blunted cortisol response later in life, particularly noted in women, indicating a kind of developmental vulnerability.
It leaves a lasting physiological imprint. Okay, finally, before we get to solutions, let's talk about something ubiquitous. Diet.
Diet has a massive impact on nervous system health, and the report details several ways specific dietary patterns can contribute to dysregulation and inflammation.
Like the typical Western diet high in inflammatory foods.
Exactly. Diets high in sugar, refined carbohydrates, unhealthy fats, and processed foods, they do much more than just affect your waistline. They are potent triggers of chronic systemic inflammation, and importantly, neuroinflammation, inflammation within the brain itself.
And neuroinflammation causes damage.
Yes, it damages neurons, disrupts communication pathways between brain cells, impairs memory formation, increases oxidative stress, interferes with synaptic plasticity, learning, and memory, and can even weaken the protective blood-brain barrier. The report is very clear. Addressing diet, specifically reducing inflammatory foods, is fundamental for nervous system health.
And nutrient deficiencies. They act as internal stressors too.
Absolutely. Your nervous system is incredibly metabolically active and requires a constant, balanced supply of micronutrients to function properly. Deficiencies in key vitamins and minerals, the report highlights B vitamins, especially B1, B6, B12, folate, vitamin D, iron, and magnesium can act as significant internal stressors. They can cause symptoms that directly mimic nervous system dysregulation or stress responses, things like fatigue, dizziness, muscle weakness, brain fog, anxiety, low mood.
Can you remind us briefly of their specific roles?
Sure. B1, thiamine, is vital for energy metabolism in nerves. B6 is crucial for neurotransmitter synthesis, like serotonin and GABA, brain development, and immune function. B12 is essential for nerve myelination and red blood cell formation. Vitamin D plays roles in immune function, bone health, but also brain development and neurotransmitter regulation. Folate is needed for DNA synthesis and repair, critical for rapidly dividing cells like those in the nervous system. Iron is essential for oxygen transport and energy production, plus neurotransmitter synthesis. And magnesium is a real powerhouse involved in muscle and nerve function, heart rhythm, hundreds of enzymatic reactions, and neurotransmitter regulation.
And these often work together.
Yes. Magnesium and B vitamins, for instance, often enhance each other's absorption and function. The point is modern diets are often lacking in these. Correcting deficiencies reduces a major source of internal stress and improves the nervous system's capacity for self-regulation. It's foundational.
Given modern food processing and soil depletion, it feels like many people could be walking around with these low-grade chronic nutrient stressors.
It's highly likely. And another very common dietary factor the report singles out is caffeine.
Caffeine. How does it fit into nervous system dysregulation?
It's directly linked to anxiety because it potently activates the sympathetic nervous system, our fight-or-flight response. The report even notes that caffeine-induced anxiety disorder is a recognized diagnosis in the DSM. Consuming high amounts, generally considered over 400 milligrams a day, or even much less in sensitive individuals, significantly increases the risk of anxiety symptoms and even panic attacks.
What's the actual mechanism? How does it stimulate the system?
Caffeine works primarily by blocking adenosine receptors in the brain. Adenosine is a neurotransmitter that normally builds up during the day and promotes calmness and sleepiness by inhibiting neuronal activity. By blocking its receptors, caffeine takes the brakes off, acting as a central nervous system stimulant. This leads to increased release of other neurotransmitters like norepinephrine and dopamine, firing up that sympathetic response.
And chronic use?
Chronic excess caffeine intake can contribute to keeping the sympathetic system in overdrive and can even dysregulate the HPA axis over time. It's highlighted as a significant dietary trigger that can perpetuate chronic stress states, exacerbating anxiety and interfering with sleep. Understanding your individual tolerance is really key here.
Wow, so it's definitely not just about feeling a bit jittery for some people. It's a direct physiological hit to the nervous system's balance. Okay, we have painted a very detailed, maybe even slightly daunting picture of how complex this system is, how it gets dysregulated by so many factors: stress, trauma, diet, inflammation, gut issues, and what that looks like in conditions like OTS, reflux PTSD. Now, for the crucial part,
Yeah.
the restoration, how does the report suggest we can actually bring the system back into balance?
Okay, yes, the solutions. The report really emphasizes that restoration isn't about a single magic bullet. It requires a multifaceted, personalized, and integrative approach. But the overarching goals are clear. We want to modulate the autonomic nervous system, basically, promote more parasympathetic rest and digest activity. We need to rebalance the HPA axis, reduce both systemic and neuroinflammation, optimize neurotransmitter function, heal that crucial gut-brain axis, and promote adaptive neuroplasticity, encouraging positive, resilient changes in the brain.
And it seems like the foundation for all of this starts with lifestyle and behavioral changes.
Absolutely. These are presented as fundamental. They are the daily practices that help shift the physiological state away from sympathetic dominance back towards parasympathetic balance. Stress reduction techniques are paramount here.
Like mindfulness and meditation.
Exactly. The report details their profound impact on neuroplasticity. Regular practice has been shown to increase the thickness of brain areas involved in self-awareness and emotional regulation, like the prefrontal cortex and anterior cingulate cortex. It can actually reduce the size and reactivity of the amygdala, our fear center. It strengthens beneficial brain connectivity, increases calming neurotransmitters like GABA and serotonin, lowers cortisol levels, and even boosts BDNF, brain-derived neurotrophic factor, which is like fertilizer for neurons.
So practicing mindfulness isn't just a nice relaxation technique. It's actively remodeling your brain structure and chemistry for resilience.
That's the science. It's really quite powerful. Then there are breathing exercises. These offer a very direct pathway to influence your ANS, specifically activating the vagus nerve.
How does that work?
Simple techniques like slow, deep diaphragmatic breathing, belly breathing, have been shown to quickly reduce anxiety and shift the ANS towards parasympathetic dominance. Coherent breathing, where your inhale and exhale are the same length, often around 5-6 seconds each, is particularly effective. Studies show it increases PNS activity, decreases SNS activity, raises GABA levels, improves heart rate variability, HRV, and reduces overall allostatic load.
And longer exhales.
The report notes that emphasizing a longer exhale, say breathing in for 4 counts and out for 8 counts, further enhances vagal nerve stimulation and the relaxation response.
Just simple breathing can have that much physiological impact. Amazing.
It's a direct lever on your physiology. Mind-body practices like yoga and Tai Chi are also highlighted. They combine mindful movement, breath awareness, and focus to actively engage the PNS and elicit the relaxation response. Research suggests they help attenuate HPA axis reactivity, modulate ANS balance, reduce symptoms of anxiety and depression, and may even influence brain structure and inflammatory gene expression over time.
And Tai Chi specifically.
Tai Chi and Qigong are noted for enhancing interoception, that ability to sense your internal body state, and fostering non-reactivity, both of which help the ANS find and maintain balance.
And sleep, of course.
Absolutely non-negotiable, the report stresses, aiming for 7 to 9 hours of quality sleep per night. During deep sleep, the non-REM stages, the PNS is dominant, facilitating physical repair, clearing metabolic waste from the brain, the glymphatic system. REM sleep is crucial for memory consolidation, emotional processing, and neuroplasticity. Sleep deprivation throws cortisol rhythms off, spikes stress and anxiety hormones, and imbalances neurotransmitters. Consistent practice of all these lifestyle techniques, mindfulness, breathwork, movement, sleep hygiene, is how you gradually reestablish balance and retrain your nervous system towards resilience.
And balanced exercise fits in here too, but with that important caveat about overtraining.
Yes, exercise is crucial, but it has to be tailored. Remember OTS. The report suggests mashing recovery strategies to the type of training stress. For instance, if someone is showing signs of sympathetic overtraining, often from high-intensity anaerobic work, they need primarily parasympathetic recovery methods: meditation, gentle stretching, massage, maybe cold exposure, naps, light resistance training.
And if they're in that paradoxical parasympathetic overtrained state.
That state, often seen with high-volume aerobic endurance training, might paradoxically benefit from some gentle sympathetic activation during recovery, like very low-intensity active recovery, slow walk or swim, perhaps supportive therapies like electrical muscle stimulation, EMS, cryotherapy, or contract baths, alongside ample rest.
So the key is really listening to your body, adjusting the load, and prioritizing rest and appropriate recovery. Exercise should enhance allostasis, not add to allostatic load.
Precisely. Now, moving beyond those foundational lifestyle pieces, the report discusses more targeted therapies specifically aimed at regulating the ANS and enhancing vagal tone.
You mean like actual vagus nerve stimulation devices?
Yes, the report mentions implanted VNS devices, which are FDA approved for specific conditions like treatment-resistant epilepsy and depression. This demonstrates the clinical power of directly stimulating the vagus nerve to modulate brain activity, influence neurotransmitter production like serotonin and norepinephrine, and improve mood and seizure control in some individuals. It validates the vagus nerve as a therapeutic target. But importantly, there are also non-invasive ways to stimulate the vagus nerve.
Okay, tell us about those. Things people can actually do themselves.
Definitely. These are simple, accessible techniques to manually stimulate the vagus nerve and encourage that shift towards the parasympathetic state. Massage is one particularly gentle massage around the head, neck, and even the earlobes, or inside the ear canal, as branches of the vagus nerve run there. Foot reflexology targeting vagal points is another.
Cold exposure, too.
Yes, cold exposure things like cold showers, ice baths, or even just splashing ice-cold water on your face, or holding an ice pack on the back of your neck. This triggers the mammalian diving reflex, a primitive reflex that strongly activates the vagus nerve, slows heart rate, constricts peripheral blood vessels, and promotes a state of calm. Regular cold exposure can improve HRV and overall vagal tone over time.
What about sound?
Humming, chanting, singing loudly, even gargling vigorously. These activities work because the vibrations stimulate the muscles in the back of the throat, which are innervated by the vagus nerve. This stimulation sends signals up to the brainstem, increasing vagal output, improving HRV, and fostering relaxation.
These are fantastic practical things people can try almost immediately.
They really are. They offer non-pharmacological ways to directly influence your ANS state,
Yeah.
nudging it towards rest and digest, reducing anxiety, and promoting calm. Then, building on the polyvagal framework, there's polyvagal-informed therapy.
Right, specifically for addressing trauma and PTSD by targeting those stuck defensive ANS states we discussed.
Exactly. The core goal is to help clients safely experience and build their capacity to access the ventral vagal state, that neurophysiological state of safety, connection, and social engagement. Therapists use various techniques to achieve this.
Such as?
Specific types of breathwork designed to regulate the ANS. Mindfulness and body awareness practices to help clients track their physiological state without judgment. Orienting and grounding techniques to help them feel safe and present in the current environment. Therapists might also consciously use their own calm presence, their facial expressions, tone of voice as a form of co-regulation for the client's nervous system. Movement and posture work can also help shift physiological states.
So it's about understanding your body's responses and learning to guide them towards safety.
Yes, it involves educating clients about their ANS responses, fostering self-compassion for those responses, recognizing them as adaptive attempts at safety, and gradually building nervous system resilience and flexibility. It often integrates well with other trauma modalities like DBT, EMDR, or somatic experiencing by providing that foundational focus on shifting the underlying physiological state out of defense and into safety.
Okay, let's swing back to nutrition. We saw how much diet can contribute to the problem, so it must be key to the solution too.
Absolutely fundamental, according to the report. Nutritional strategies are presented as a cornerstone of restoration. The primary recommendation is adopting an anti-inflammatory diet.
Which basically means reducing foods that promote inflammation and increasing foods that fight it.
That's the essence. Reducing intake of processed foods, refined sugars, unhealthy fats like trans fats and excess omega-6s, and potentially individual trigger foods. And consciously increasing intake of foods known to combat inflammation.
What are some key anti-inflammatory foods the report highlights?
Omega-3 fatty acids are crucial, found in fatty fish like salmon and mackerel, as well as flax seeds, chia seeds, and walnuts. They directly counteract inflammatory pathways and produce anti-inflammatory signaling molecules. They also influence those microglia in the brain. Colorful fruit and vegetables are packed with antioxidants and phytonutrients that combat oxidative stress and inflammation, protecting nerves. Spices like turmeric, with its active compound curcumin, and ginger have potent anti-inflammatory effects and may help alleviate neuropathic symptoms. Healthy fats like extra virgin olive oil and avocados, whole grains for fiber and stable blood sugar, lean proteins, and of course, adequate hydration.
So this type of diet directly targets that systemic inflammation we talked about, creating an internal environment more conducive to nervous system healing.
Exactly. It also helps stabilize blood sugar, provides essential nutrients, and supports overall metabolic health, all of which reduce stress on the system. And alongside the general anti-inflammatory pattern, there's specific focus on gut microbiome support.
Right, because the gut is so central.
Yeah.
How do we actively support it?
Optimizing gut health is presented as non-negotiable. We know the microbiome influences everything from neuroinflammation to neurotransmitter production to behavior. So strategies focus on restoring balance and diversity.
Like probiotics.
Yes, the report highlights probiotics, beneficial bacteria found in fermented foods like yogurt with live cultures, kefir, sauerkraut, kimchi, kombucha, miso. Consuming these regularly can help modulate gut microbial balance, strengthen the gut lining, improve gut-brain axis communication, and potentially influence brain function and mood. Some studies suggest probiotics can reduce stress cortisol levels and affect neurotransmitter expression.
And prebiotics.
Prebiotics are types of dietary fiber that act as food for our beneficial gut bacteria. They're found in foods like onions, garlic, leeks, asparagus, bananas, especially slightly green ones, oats, apples, and chicory root. When beneficial bacteria ferment these fibers, they produce those incredibly helpful short-chain fatty acids, SCFAs, like butyrate, which have anti-inflammatory effects throughout the body, including the brain, and serve as fuel for gut lining cells.
What about symbiotics?
Symbiotics are combinations that include both probiotics and prebiotics, designed to work synergistically. The report notes some evidence suggesting symbiotics might be particularly helpful for certain mental health conditions. The overall message is clear. Optimizing gut health directly influences neurotransmitter synthesis, reduces gut-derived inflammation, and modulates that critical gut-brain communication pathway. It's a fundamental step for improving mood, anxiety, and overall nervous system resilience.
And addressing those specific nutrient deficiencies seems almost basic, but clearly critical.
It's fundamental targeted repletion. If deficiencies exist in those key players, B vitamins, vitamin D, iron, magnesium, maybe others like choline, which is important for nerve signaling, correcting them, provides the essential building blocks and cofactors the nervous system desperately needs for energy production, nerve impulse transmission, neurotransmitter synthesis, and managing oxidative stress.
It's like trying to run a complex machine without the right fuel or lubricants.
Exactly. The report points out that many individuals, due to diet, lifestyle, or certain health conditions, are likely deficient. Assessing for and correcting these imbalances reduces a significant source of internal physiological stress, improving the system's overall capacity for self-regulation and optimal function. It has to be considered.
And, logically, avoiding the triggers we identified earlier must be part of the plan too.
Absolutely necessary for restoration. Consciously reducing or eliminating triggers removes ongoing sources of irritation and dysregulation. This includes minimizing processed foods and excessive sugar, which fuel brain inflammation, cause oxidative stress, disrupt gut health, and deplete nutrients. Limiting or avoiding caffeine, especially if you're sensitive, to reduce sympathetic overdrive and HPA axis strain. And moderating or avoiding alcohol, which can directly damage the ANS over time and worsen issues like reflux.
Taking away those constant hits allows the nervous system space to calm down and begin to heal and restore balance.
Precisely. Finally, the report touches on several complementary and integrative approaches that can further support nervous system restoration.
Like acupuncture.
Yes, acupuncture is mentioned. Research suggests it can stimulate the release of various neurotransmitters, including endorphins for pain relief, but also serotonin, dopamine, and GABA, which influence mood and relaxation. It's thought to help balance the ANS, potentially shifting it towards parasympathetic activity, and may affect stress hormone levels like cortisol. There's also evidence it can induce neuroplastic changes in the brain, improve cognitive function and emotional regulation, increase cerebral blood flow, and boost levels of BDNF.
So it's acting on multiple levels relevant to nervous system health.
It appears so. It's presented as a potentially valuable tool for a range of conditions associated with dysregulation, including pain, headaches, anxiety, depression, and even digestive issues. A comprehensive approach.
What about biofeedback and neurofeedback?
These are fascinating tools for enhancing self-regulation. Biofeedback provides real-time information about physiological processes, usually outside our conscious awareness, like heart rate variability, skin temperature, muscle tension. By seeing this feedback, individuals can learn techniques like breathing or relaxation to consciously influence these processes and gain better control over their ANS responses. Neurofeedback is similar, but focuses specifically on brainwave activity, training the brain towards healthier patterns associated with focus, calm, or stability.
So you're learning to consciously regulate your own internal state.
Essentially, yes. It's a way to train your nervous system to manage stress and anxiety more effectively from the inside out. Herbal remedies and adaptogens are also discussed.
Adaptogens help the body adapt to stress, right?
That's the idea. These are specific herbs believed to enhance the body's resilience to physical, chemical, and biological stressors. They work in part by modulating the HPA axis and helping to normalize cortisol levels, preventing excessive spikes or prolonged elevation. They might also influence neurotransmitters like serotonin and dopamine, reduce oxidative stress, and potentially promote neuroplasticity by increasing BDNF.
What are some examples?
Classic examples mentioned include herbs like ashwagandha, rhodiola rosea, ginseng, various types, holy basil, tulsi. They offer a kind of multi-targeted natural support system for enhancing stress resilience and promoting balance.
And lastly, psychotherapy has a role.
A crucial role. Therapies like cognitive behavioral therapy, CBT, help individuals identify and change negative thought patterns and behaviors that contribute to stress and anxiety. Trauma-focused therapies like EMDR, eye movement desensitization and reprocessing, or somatic experiencing, SE, are specifically designed to help process traumatic memories and regulate the intense ANS responses associated with them. Many therapies now explicitly integrate ANS regulation techniques like breathing and relaxation exercises into the process.
So therapy addresses the psychological and behavioral components, but also directly influences the physiological state of the nervous system.
Absolutely. It helps manage stress perception, build coping skills, process unresolved emotional issues, and ultimately helps the nervous system learn new, more regulated ways of responding to life's challenges.
Okay, so bringing this all together, the report paints a picture of nervous system dysregulation as this incredibly complex, interconnected issue. It involves a dynamic interplay between your autonomic nervous system, your HPA axis, your immune system, your gut, all triggered by this wide array of stressors: physical, psychological, environmental.
And it manifests physically.
Yeah.
As real, measurable changes in brain structure, brain chemistry, gut-brain communication, inflammation levels, leading to the tangible conditions and symptoms we discussed, from fatigue and anxiety to gut problems, and even how we respond to exercise or trauma.
But, and this is the hopeful part, the report also clearly lays out a comprehensive path towards restoration. It emphasizes that we can influence these systems. We can modulate the ANS, rebalance the HPA axis, reduce inflammation, optimize neurotransmitters, heal the gut-brain connection, and promote positive adaptive brain changes.
Exactly. Through that rich spectrum of evidence-based interventions we've covered, starting with those fundamental lifestyle changes, stress reduction techniques, sleep hygiene, tailored exercise, adding targeted approaches like manual vagal stimulation or polyvagal-informed therapy where needed, implementing critical nutritional strategies, the anti-inflammatory diet, gut microbiome support, targeted nutrient repletion, and avoiding key triggers. And considering complementary methods like acupuncture, biofeedback, adaptogens, or psychotherapy as part of an integrated plan.
It's a truly integrative view, isn't it? Really acknowledging how inseparable mind and body are in this whole process. And looking ahead, the report suggests the future lies in more personalization.
Yes, the need for more research, especially longitudinal studies tracking people over time, developing more personalized approaches, perhaps tailoring interventions based on an individual's specific profile, their unique neurotransmitter patterns, HPA axis function, microbiome composition, understanding the synergistic effects of combining different therapies, and using more sophisticated diagnostics to identify specific patterns of dysregulation earlier on.
There's always more to learn, definitely. But the foundation for understanding and, importantly, supporting nervous system restoration seems really well laid out here.
It provides a solid framework and a lot of actionable strategies.
So here's a final thought to leave you with. Considering how fundamentally things like chronic stress and our daily lifestyle choices can literally rewire our brain and body towards dysregulation, What does all this reveal about the power that you have? Through conscious effort, through informed choices, to actively participate in rewiring yourselves back towards balance, health, and resilience.
It really suggests that while the system is complex and certainly vulnerable to the pressures of modern life, it also possesses this remarkable inherent capacity for healing and adaptation, especially when we give it the right support. Our daily choices, our consistent efforts, they genuinely have the potential to be powerful interventions for our own well-being.
That's a really powerful thought to sit with. Thank you so much for guiding us through this incredibly detailed deep dive.
It was my pleasure. Fascinating topic.
We certainly hope this dive into the intricacies of the nervous system has given you some valuable insights and maybe some actionable ideas to explore. Until next time on The Deep Dive.